Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 10.2. This is on parabolas. Now, I know we've been introduced with parabolas using usually a different formula. We've seen a couple of different ones. One is just like the y is equal to ax squared plus bx plus c. That's just kind of like a normal quadratic, which gives us a parabola. And we've also seen the parabola form, or the vertex form of the parabola, and that's y is equal to, and I'm going to write that down up here. Oops. We've also probably seen this one. Y is equal to a times x minus h, quantity squared, plus k, where hk is our vertex of that parabola. And a is positive if it's going upwards, and a is negative if the parabola is opening downwards. All right, but here in this book, they kind of introduce the equations a little bit differently, and they talk about them a little bit differently. So in order to solve this problem, we're going to go ahead and use their equations, which we can do. And this will also help for the project as well. For the project, you're welcome to use the book's equations or the vertex form. Either one of those are fine. Yeah, just make sure that you're kind of consistent throughout your work. So let's go ahead and do this. So we have an equation here of a parabola. It opens upwards, and the y-axis is the axis of symmetry. That means that everything on the left side of this y-axis will be a mirror image of everything on the right side of this y-axis. And it also contains these 2 points, -4, -3, and -6, 0. So let's go ahead and just kind of do a quick makeshift graph just to see what this thing's kind of going to look like here. So -4, -3, so we'll go 1, 2, 3, 4, 1, 2, 3. So we've got some point that's on this over here, and then we've got another point that's going to be over here. And remember that this thing is going to be, so it's going to kind of look like this. So it's going to be symmetric to the y-axis here. So we should get something that looks just the same on this side, and it'll go up like this. So we should expect points over here of 4, -3, which will be right about there, and 6, 0, which will be over here as well, since this thing is symmetric there. And we don't know the y value of our vertex here. We don't know this, but we do know the x value, since this is the axis of symmetry. So this is going to be 0, some value there for y, but we don't know that vertex yet. All right, let me just 6, 0, and this is going to be 4, -3, 4, -3. This here will be -4, -3. And this one here will be -6, 0. All right, so this is what we've got so far. So let's see how we can use these equations up here to help us find the formal equation that contains all of these points, and we can actually figure out our y value of our vertex as well. So this is opening up, so it looks like I'm going to use this third equation here. So I've got x minus h, quantity squared, is equal to 4a y minus k. All right. Now, in order to solve this, let's see. hk, that's going to be our vertex. So we already know that the x value of our vertex is 0. So I can already kind of reduce this to looking something like this, for a times y minus k. Now, I don't know what my a is, and I don't know what my k is, but we do have values for x and y. I can use any of these points on here. I'm going to go ahead and just use these 2 right points here. You definitely don't want to use 2 points that are on the same horizontal line, because you're just going to basically get the same equations there, because remember, we're squaring x. So 6 squared is the same as -6 squared, so that's not going to really help us solve this. So I'm going to use 2 points that are on kind of different horizontal lines there. So we'll use 6, 0, and 4, -3. I could have just as easily used -6, 0, and -4, -3. Both of those will work. So if I use 6, 0, I'm going to substitute 6 in for x, 0 in for y, and I'm going to get 6 squared is 36 is equal to 4a times my y there is 0, so 0 minus k. And that's going to give me 36 is equal to -4ak. And I'm going to go ahead and stop there for now. I mean, I could solve for a, I could solve for k, but let's not worry about that yet until we see what the other equation looks like when we use the other point. So using this same equation here with another point, that 4, -3, we're going to square the 4, so we're going to get 16 is equal to 4a, and then our y for that is -3, so that's going to be -3 minus k. All right, so notice we're going to have 2 equations and 2 unknowns here, and hopefully we remember how to solve those, but I think this one's going to turn out a little bit easier than we think. All right, so this is going to be 16 is equal to -12a, -12a minus 4ak. All right. So notice something here, that we have this -4ak coming up twice, right? And so actually, I'm going to go ahead and just multiply both sides by a negative here. So that's -36 is equal to 4ak. And there, I can substitute this 4ak over here for -36, and I don't even have to do all that elimination by addition stuff, right? So this 4ak is on both sides, and we know that 4ak is equal to -36, so I can just put in my equation here, 16 is equal to -12a minus that, minus a -36, right? -36. Be careful about your pluses and minuses. So this is going to be 16 is equal to -12a plus 36. Subtract 36 from both sides and kind of switch them around. -12a is equal to 16 minus 36, which is -20. And a is going to be equal to, divide both sides by 12. So that's 20 over 12, which is going to reduce down to, let's see, 4 goes into this 5 times, and 4 goes into that 3 times. So this is going to be 5/3. So that is our A right here. A lot of work to get our A. And let me kind of move this a little bit, give us a little bit more room here. But let's see what we can do with that. Now that we know our A, I can go ahead and put it back into this formula up here. So we're going to go back, and I'm going to, oops, let me change it back to pen. So I've got x minus h, quantity squared, is equal to 4, here's my A, times 5/3 times y minus k, right? Times y minus k. All right. So this should allow us to solve for this k, right? Because now, once again, we know that h is 0, so x squared is equal to, that's going to end up being 20/3, 4 times 5, so 20/3 times y minus k. Once again, I'm going to put a point in there. I'm going to go ahead and put the one that has a 0 in it. So I'm going to put the 6, 0 or negative 6, 0, but I'll do 6, 0. So if we put 6, 0 in there, I'm going to get 36 is equal to 20 over 3 times 0 minus k, right? Because 0, 6 is a point, and I just plugged that in there. So this is going to give us 36 is equal to negative 20 over 3k, 20 over 3k. And one thing you may not have done too much, but it's a nice little trick here, is that whenever we have a fraction multiplied by the variable, we're trying to solve for that variable, I can multiply both sides by the reciprocal of that fraction. So by negative 3 over 20, and that'll cancel out both of those. And then we do the same thing over here. So didn't leave myself enough room, but let's do it that way. And we can do negative 3 over 20. And so that negative 3 over 20 times 36. I think that's one of those. Let me see, 3 times 36. All right, and then we're going to divide that by 20 and convert that back into a fraction. And that's going to be a negative. So 27 over 5. So this is negative 27 over 5 is equal to k. So that we just solved for the y value of our vertex. So that means that the y value is about exactly negative 5.4. And if we go back here, notice that that makes sense, doesn't it? Because this point here goes to negative 4. This y value here goes to negative 3. So it's still going down. So negative 5.4, that looks just about right. All right, so plugging this all back in. I know it's a lot of work, but we're going to use, once again, this third equation here with everything that we know now. So we have x squared, because it's x minus h, but we know h is 0. So x squared is equal to 4a, that's going to be 20 over 3. 20 over 3. And then times y minus k. So that'll end up being y minus a negative. So y plus 27 over 5. And this right here is the equation of the downward opening parabola that goes through these 2 points. Upward opening parabola, that goes through these 2 points right here, is symmetric with that y-axis. And it's not in the normal form that we're used to, but if we wanted to put it in the normal form, it wouldn't be too hard, right? We could just distribute through and then solve for y. So distribute through and then solve for y. All right, I hope this helped. And once again, this should help on the project number 2. All right, hope everybody has a great week. Thanks.